Okay, this video is going to be about the dictionary data type in Python 3. In the last video we learned about the list data type, which is a collection of values. It's essentially a series of values, and you can reference the individual values by their index number. Okay, with the dictionary you can reference individual values with a name. Okay, so instead of an index number, you literally name every single value. So this is what's called a key value pair. All right, so dictionaries are basically lists of key value pairs. All right, so here's a basic, I've opened our notes file here. This is a basic Python definition of a dictionary. Okay, so you have an identifier, and this is an assignment statement, so we have the assignment operator, and then this is a dictionary literal. You use curly brackets. So for the list, we used square brackets. Okay, that's an empty list. And in Python 3, this is an empty dictionary. Alright, so this dictionary has 3 items in it. There's the key, and then this is the value of that first key. So this is, for example, the dictionary name is test scores. So you might have 3 exam test scores in here. Exam 1, that's your score. The name of this value is exam 2, and that's your score. Okay, so notice how these are constructed. We have the identifier, the assignment, and this is the dictionary literal itself. Left and right curly braces. Now each line of this dictionary is constructed with a string key, so that's just use quotation marks, any string, and then a colon, and then a space, and then the value associated with that string key. Okay, so this is the key, and this is the value. And then just like in lists, for the next item, you separate them by commas. So if I want to add another item to my dictionary, add a comma, and then go to a new line. You don't have to go to a new line, but it's common with dictionaries because you might have several items in your dictionary. All right. So for each one of these, I could have something like this. A is the key, and that could equal 10. And then I could say B, and that could be 20, something like that. This is a valid dictionary. Okay, but it's common to put them each on one line. Okay, and the last one, you don't have to have a comma at the end here, but it's kind of nice because if I want to move where in the dictionary this item is located at, if I don't have the comma on the last one, I'd get something like this, and there'd be an error in Python. So I always like to add the comma to the last one. That way I can move these values around however I'd like. Alright. So again, this last comma is not necessary, but I recommend it. Alright, so these are 2 examples of dictionaries. This one is a player dictionary. Previously, we worked on a player list, where the first item of the list at index 0 was the last name, and then the second item in the list, which is index 1, was the first name. It gets complicated trying to reference the individual items in the list because you have to associate those numbers with what type of data is actually stored there. That's one thing that's nice for a dictionary. Okay, so this is a perfect implementation. We can do the same exact implementation we did with lists, but it's going to be much easier to understand because we're going to be using named values. So we'll say we're going to look at a player object, but I want to look at the last name. And it's going to be obvious that that's what I'm talking about because I'm actually referencing the last key or first key or position key to reference a value in that object. Okay? So let's go ahead and open up Python in interactive mode and define these 2 dictionaries. Let's save that file real quick and open up. Let's cd into our desktop. Python 3 interactive mode, and I'm going to go ahead and let's copy this in here. Test scores. Alright, and you see when I type it out in interactive mode, this is an expression, and it evaluates to this value. This value is a dictionary, or a collection of named values. Alright, and then we'll copy this one in here. So the two dictionaries we're going to be working with are test scores and player. And if I type player, we see Python prints out the player properly. Right. So just like with list, we can determine the type of data. Right. We've done this for every data type we've learned about so far. So let's look at the type of data held in the variable called test scores. That's the class dict. That's short for dictionary. Okay. So just like strings, the type of string, pass in an empty string. The class is str. That's short for string. So dict is dict, and it's short for dictionary. So I can do the same thing that we've done for every type of data type. Let's look at the type of test scores, and I can say, is it a dictionary? Is dict. And this is going to either be true or false. Is this a list? No. Okay, I can do that for either one of them. Player. Okay, so that's nothing new. We've used the type function lots of times, but for every data type we learn, we go ahead and demonstrate that. All right. So we'll look at the type stuff. Then we can also do length. Let me add this to our notes. We've got type. That's what we just did, and then length. So just like lists, we can determine how many items are in our dictionary. So what is the length of test scores? There's 3 items in our test score. 1, 2, 3. In a list, instead of having a string value as the way to reference it, it would just be the index, which in this case, this one would be 0, this one would be 1, and this one would be 2. Okay? It's more concise to make lists, but it's also hard to understand what types of data you're pulling off. If we look at our previous example, player list here, when I'm referencing the individual items in the player, so here's a player object. It's a list. This is the last name is index 0. So last name, index 0. The first name is index 1. Position is index 2. So down here I'm referencing each one of those items, but it's hard for me to just look at this and know what type of data is here. Okay, because it's all based on the index. If I can't see this stuff up here, then it's really, I have no real idea what this string is printing out. Okay, the only one that I'm aware of is health, because that one should have something to do with health. Alright, so we're going to do a demonstration of the same program, except with a dictionary, and you're going to see how much easier it is to understand the data you're working with. And that's where dictionaries shine. They allow you to understand a little bit more about the data stored in your collection, because each value is named. Alright, so let's go back to our notes here. We've got the length of test scores that yielded 3, and we want the length of player. Okay, so player had 4 items in it in this case. Alright, we can convert, because this is a collection, we can convert to lists. Okay, so this is interesting. This is something new that we didn't do with lists. Convert to list. Okay, so it makes sense to convert either the keys to a list or the values to a list. All right, so when we look at our dictionary, we can have all of these be a list. So a list could be all the keys, or all of these items be a list, and the values. All right. So to convert that to a list, it's just like we convert one type of data to another in Python. We convert integer data to strings using the string function. We convert string data to an integer using the integer function. So to convert a dictionary to a list, we're going to use the list function. All right, so or we could actually. Let's see. Actually, let me see if that works. List. Yeah. So if you use the list function by itself, it gives you the keys. All right. do exams, or what is it called, test scores. There we go. This is going to yield, let's just copy and paste to make it quicker. If I run this, this is going to yield the list of the keys. Each one of these on the left is the key, and this is the value associated with that key. Alright. I can also use the dictionary itself. There's an attribute attached to it, test scores, and I can say dot keys as a function and call that. This returns the same thing. Alright, so let's run that in Python. Test scores dot keys. Okay, dictionary keys. This one is slightly different. This one is an iterable, and this one in most cases is going to be the way you want to do things. Your dictionary might have thousands of items in it. If you do it like this, this dictionary, you don't commit all of those keys to memory right away. You construct them as you need them. I know that's a little bit advanced, and you'll go over this more in further classes in computer science. If I use this version, I'm taking every single one of these items and converting it into a list, and each one of those items is stored in memory. Okay, so let's say I might even have 10,000 or a million items in my dictionary. That's entirely possible. And if I call list and then my dictionary, that takes every single key in those million items and stores it in memory. Okay, using it this way, it does the same thing except without actually generating the values. And then whenever I need a particular value, then it creates it and stores it in memory. And then when I'm done with it, it deletes it. So this particular method saves a whole lot of memory. And it's a very nice, it's one of the key differences between Python 2 and Python 3. It's a nicety that saves on a whole lot of computer resources. Okay, but it is a little bit complicated, and it's a little bit outside the scope of this introductory course. All right. So just know that whenever using dictionaries, generally speaking, you're going to want to use the dot keys function. Alright, and then if I want to get the values, I can say, instead of dot keys, I can say dot values. Okay, and again, this is essentially a list. Right? If I want to make it explicitly a list, I can say dict dot or test scores dot values. Now it's actually a list. All of the values are stored in memory all at once. Okay. So I have to explicitly convert that to a list to make it a list. So it adds a little bit of complexity, but it actually saves a whole lot on memory and resources, which is one of the big reasons they changed versions from Python 2 to Python 3 to make everything more efficient in this way. Okay, so this essentially yields a we'll call it a list-like object, or an iterable, because you can iterate through the items of it just like a list. When we talked about the for loops before, the for loop iterates through this item. What I mean by that is the first time through the loop, it's this item. The second time through the loop, it's this item. The third time through the loop, the variable is that item, right? So it iterates one item at a time. That's what iterate means. So if an object is iterable, you can do that. You can go from one item, and there should be a next item and a next item until there's no more items. That's what it means to be iterable. So using this function, it is iterable, but it's not actually a list, and you aren't wasting a whole lot of memory. Okay, then to get the values, we can say, if we get the list version, we'll go ahead and do player. So list of the player, that's going to give us the keys, but it's going to convert it to a list. So all of these keys are actually going to be stored in memory. which is not a big deal if there's only 4 or 5, but it is a really big deal when there's 1 million or 5 million or 1 billion, which is possible. Some databases have very, very, very large numbers of items. All right, so list player, is that going to yield this actual list? Okay, and if I say player.keys, that's going to yield a list like iterable. Okay, my dictionary doesn't know that word. All right, so we can do the same thing with values. I can say the list of test scores dot values is going to actually give me the list of those values, which by list I mean it's actually going to store each one of those values in memory in a list. Okay, so this is going to be, we'll find out what this yields by running it in Python. So we're in interactive mode. Okay, so this actually gives us this list. And you see these are the items in our dictionary. These are the values of each item in our dictionary. Okay. Now if I run test scores.values by itself, this is going to yield the list-like object that's iterable. Okay, so if I run this in Python, okay, and again, all this does is save memory. You can iterate from one item to the next, just like in the list. However, you don't have to store all the values in memory until you actually need that value. All right, so that is the score, test scores, and then we'll do the player version. So list player.values. Let's see this field. We run this in Python, and this is the list that contains each of these values from our player variable. Okay. So again, we're converting a dictionary to a list, but since there's keys and values in a dictionary, you can either convert the keys to a list, or in this case, we're converting the values to a list. And then the other version would be player dot values, and we don't explicitly convert it to a list, so this is a list-like object, and it's an iterable. So we can use it for practically all the same things we can use a list for, specifically in for loops. We don't need a list, we just need a list-like object. We need an iterable. Okay, so that's converting to lists. Now let's do something we learned about with lists. We want to access an individual value from one of our dictionaries. Okay, with lists you would type the identifier name, and then square brackets, and then the index of that value. Okay, well, we don't have indexes or indices in dictionaries. We have key values, key names. Okay, so I type in my variable that's holding my identifier that's holding this dictionary, right? Test scores is holding this dictionary. Then I use square brackets just like with the list, but instead of inserting a number here, an index value, I'm inserting the key as a string. It's important that it's as a string. You have to have quotation marks. So if I want to get the third item from this list, the value associated with the key exam3, that should be this value, 96.5. This should yield 96.5. So let's try that. We try test scores, and we're accessing an item. Okay, so in all collections in Python, to access an item within that collection, you use square brackets. In lists, you use square brackets, or in dictionaries, or any of the other collections in Python. You use square brackets to access an individual item. Now, in lists, the key is always an index. In a dictionary, the key is a string. So Well, for our purposes, it's a string. It can actually be other things, but we're going to see what exam3, what that key is. All right, and sure enough, exam3 is associated with this number. So you can see how this is a little bit nicer. When we see test scores exam3, we know, oh, okay, that must be the test score that they got on exam3, as opposed to the list version of that would be something like this. Test scores 2. Well, I'm assuming that's the second test score because these are test scores. But what about if I had something like player 7? That's the seventh field in a list of items about a player, right? That's harder to tell what that might be, right? However, if it says something like, you know, jersey or number or something like that, that tells you that's the player's number or jersey number. These keys can have spaces in them. Okay, so just like any string, strings can have spaces, right? So the keys can also have spaces. And even new lines and tabs. I don't recommend you do it, but you can. Okay. So accessing exam3, and then let's look at the last name of the player. We'll say player last. What is this going to yield? This should yield the string luck for our particular definition of player up here, right? So let's run this in Python and see if we're correct. So remember, it's the identifier, square brackets, and then what goes inside the square brackets is the key, and what gets returned is the value. So this is an expression, and expressions get evaluated to one value. This expression becomes evaluated to this string, luck. Alright? So you can add items to a dictionary just by defining a new key. So let's look at these two items. I'm just copying and pasting this to save time. You don't have to watch me type all this out. Changing a dictionary item. So if I wanted to change the score of exam2, this is like the list example we did. I wanted to add 5 bonus points. So I reference test scores, which is a dictionary in this case, the item at key exam2, and then I'm going to say I want that to equal whatever it did before, but add 5 to that. Okay, so this adds 5 bonus points to the item at exam2. So let's run this. First, let's look at test scores. Okay, so we're going to be changing exam2, 77.4. So we're going to say test scores, square brackets, and inside the square brackets is the string for the key of the item that we want to change. We want to change the item at exam2, and we're going to take whatever it was before and then add 5 to it. Okay, and we look at test scores again. We see exam2 has 5 added to it. Alright, another version is, let's say Andrew Luck, we don't have injured here. Let's add that. Let's say it was true. So I changed my dictionary, so I have to paste it back over here. We'll look at player again. Alright, see we have injured there, and we'll say it starts out as true. So that would make the length here, instead of yielding 4, it would yield 5, because there are now 5 fields in this. Okay, so we'll change that. And then this would change to there you go, and this would change to true. Okay, so I have updated the notes so it works with this new value. Alright, so if I want to look at player injured, I want to set that equal to false. So if I look at player, I have this field, the key name injured, and it's true. I can change that and say player, once he's healed, I can change his attribute from injured to or the key injured, I can change that value from true to false. And if I look at player again, now it's under injured, it says false. Alright. And I could say player injured equals whatever it did before, and since this is a Boolean value, I can invert that, and I could say not player injured. So if player injured was true, not true is false, so player injured becomes false. If player injured was false, not false becomes true. So every time I run this bit of code, it toggles the value of injured. I run it again, now injured will be false. Injured is false. Run it again, injured will be true. Injured true. Run it again, false. Okay, so this is a method for toggling a Boolean value. To toggle means to alternate from one value to another. Right? So it's a common term you'll hear in computer science. Alright, so that's changing the item. You just use the identifier and then the key name and then set it to whatever value or modify it to whatever value you want. Okay, to remove items from a dictionary, you can do it in two different ways. It removes an item at key. So if I have oh, I forgot the section of adding items. There we go. That is supposed to go up here, which is why this wasn't here. Apologize for that. Let me fix all this again. This is going to yield 4. Injured won't be there. That won't be there. Alright, I think that's it. So, if you want to add an item to a dictionary, you just reference the identifier and then a new key name, even if the key name doesn't exist, and then set the new value. Okay, so test scores, exam 4, we're going to set that equal to 99.9. So let's look at test scores and see what we have. There's 3 items, exam 1, exam 2, exam 3, and I want to say test scores, and I'm going to make a new one, exam 4, and I'm going to say that value is going to be 99.9. Okay, that's a statement. It's an assignment statement. Now if I look at the dictionary, there it is, exam 4 shows up. Now there's 4 items in my dictionary. I can use the length function to look at how many items are in the dictionary. There's 4. Right? And then here, player injured, this is where I add that value. And we look at player, and now we have the injured value and true. Right? I can change the dictionary item from injured true to false. Okay, so now when I look at the player, injured is false. Alright, now removing items from the dictionary. Let's say we want to remove that item that we just created. Right? There is a keyword in Python called del. It stands for delete. So I want to delete one of the items in my dictionary, test scores. What item do I want to delete? I want to delete the item at key exam 4. Oops, test scores is what I need. Test scores. Now we no longer have that item at exam 4. Up here when we called test scores, we had an item for exam 4. Since I called delete test scores, we deleted that item from our dictionary. And now our dictionary only has 3 items in it. The length of it is 3. Alright. There's another way you can remove items similar to lists. You can use the pop function. So I can say is injured, and this is similar to the way lists popping list values works. So I have a variable name called isInjured, and whatever item I remove from my dictionary, player, I want it to be stored here. So this is doing two things. Player.pop is removing an item from my dictionary, but it's also taking that item that was removed from the dictionary and then storing it in here. So it's doing two things, and it's important you recognize that. Okay, so player.pop, what item do I want to pop off of my dictionary? The item associated with the key injured. Okay, so let's look at my dictionary again. Player, we see injured is gone. Up here we had a key injured. Now it's gone. And let's look at the variable we made is injured. Sure enough, that's where that value went. Okay, so this is doing two things. All right, so that's removing items from the dictionary. Okay, and that's the basics of a dictionary. It's not that much different than a list, except that you have named values. So you have a key value pair, right? And because of that, you can't really do slices necessarily. It becomes more difficult because slices make sense with numeric slices, but it's harder to do slices with names, right? But what you can do is if you want to do slices, you can convert the names to a list, or the keys to a list, and then take slices of those keys, and then it's sort of like you can construct another dictionary from those keys. All right, so if I have player and I want to kind of take slices of this, instead of taking slices of the dictionary directly, I say player.keys. So that's last, first, position, and jersey. And let's say the slice I want to take is these last two items. So to do the slice, I would say from -2 to the end of the list. Oh, I need to convert that to a list first, not a list-like object. Okay, so that's position and jersey. And then I can make a new dictionary, call it DI. Make an empty dictionary, and I can say DI for the first item in this list. Right. I'm going to have to set that to a variable. Li equals list. So Li contains the two items from the dictionary that I want, and I made an empty dictionary, DI, and I can say I'm going to add to this dictionary the item, the key is list item 0, and I'm going to set that equal to player list item 0. Okay, so list item 0 is position, right? This is the string position. This is the string position. So all I'm doing here is I'm saying add a value to my empty dictionary, add the value with key name position, and set that equal to the value at my other dictionary called player, that value stored at key position. It's essentially saying this. In my new dictionary, DI, I want to set the key position equal to the value stored in my player dictionary at key position. I'm basically duplicating the key value pair from this dictionary over to this dictionary. Okay. So if I say DI, we see DI now has one value in it, and its position. And then I can do the same thing with the second item in the list, or the one index item, and get the jersey. Okay. And if I look at dictionary, we have now two items in the dictionary, position and then jersey 12. Take a minute and look at this and understand what's happening. Okay. A lot of computer science gets into nested evaluations of things. Okay. We have a dictionary, and then everything inside the square brackets is a key. What does this evaluate to? Well, let's look at our list value. Li has two items in it. What's 1? What's the item at index 1? Well, that's going to be jersey. So that means inside of here, it's basically the string jersey. So we're looking for the item in the player dictionary at key name jersey, which is the value 12. That's all this is saying. When you look at it like this, it's kind of complicated, but take your time as you go through and look at the individual pieces. Alright, so let's go ahead and do some examples. We're going to do the player dictionary version. Last time we did player list, and we'll open that up and we'll compare basically at the end how this string looks much better using the other version. Using a dictionary, we understand instead of seeing these index values, we're going to see strings, and we'll know what data we're trying to access. Alright, so let's do that real quick. New file. This is going to be called player. So this is the dictionary version. So let's just start off so I don't waste time typing. So this is a basic dictionary. It's just like the other dictionary in player list. Okay. In player list, we have this data, right? We could make it look more similar by doing it like this. But you see it's essentially the same data. Okay. Over here, so Luck, Andrew, QB, 12 false. Over here, Luck, Andrew, QB, 12 false. The only difference is instead of using an index, we're using a named key for each of these items. Alright. So again, I'm going to use the offense identifier, and this is still going to be a list. Previously I had a list of lists. This time I'm going to have a list of dictionaries. Alright? So offense is still going to be a list of items, but each one of those items is going to be different. It's going to be a dictionary instead. So let's say offense. Now how do you add an item to a list? Append. Append. And I'm going to append. What am I going to add to my list? I'm going to add whatever's stored in the variable player. Now we make another player and set player equal to the stats for Marlon Mack. Okay, so player, and I'm just pasting this in to save time, but we have the same keys. We have a last name, first name, position, jersey, injured, location, and team. Last, first, position, jersey, injured, location, and team. This is the same data as in our other version. If we look over at Marlon Mack, this is the same information. It's just in a dictionary format instead of a list format. We're going to add this guy to our list. Offense.append player. Actually, let's put offense up here. This is going to look a little more consistent. Okay, so you define the player, then add the player to offense. Define the player, add the player to offense. Alright, and then we had T.Y. Hilton, and we'll just go ahead and do the same thing there. So last, first, position, jersey, injured, location, team. Same stuff. So now we're going to print out this variable offense, and you're going to see the difference. Instead of being a list of lists, it's going to be a list of dictionaries. So ls, we're running player dictionary.py. So Python 3 player dictionary version. So here, we have a lot of information here. So it looks kind of messy, but if you look at it, we have a beginning square bracket. That tells us it's a list. So all the way at the end, we see a closing square bracket, which is the end of our list. Okay? So that means all of these items in here are our list. So let's look at, we have an opening curly brace, so we want to look for a closing curly brace in here, and that'll be the end of our first item. Okay, we don't see it anywhere on this line. It comes all the way down to here. So this whole thing is our first item in our list. This is the offense variable. This is one of our players. This is just like our list of lists, except each one of these values has a name instead of an index. Here's the second item in our list. Notice the comma. The items in a dictionary or a list are separated by commas. So here's the second item in our list, and we have open curly brace, and we look for the closed curly brace. All right. Now this is Marlon Mack. That's the second item. We have another comma. Here's the opening curly brace and the closing curly brace, and this is the last item in our list. All right. We can print out the length of it too. Length of offense, and it should be 3 because there's only 3 players that have been added to our list so far. And there's the 3. All right. Alright, so we'll print out a little line, and we want to make a function to print out this information. Right? So for P in offense, or we'll say player, what we're going to do is we want to make a function that's going to print off this player information, but we want to format it better. So first let's just do a for loop and print off each of the items in this list. Okay, and we'll see what that looks like. Okay, and this is just our individual dictionaries. It just prints them out, and this is kind of hard to read. It doesn't print out neatly, right? But the computer understands this very well. These are key value pairs separated by commas. This is obvious to the computer. What we want is, like most users would never understand what this is. We need to format this in a way that humans can read. Say we're making a web page or any number of things. We're making a document, an output file. This is not good enough format. What we need to do is format this in a way that people can understand. Okay, so what we're going to do is we're going to make a function to do that. And we're going to say define a function, and this is going to say print player. All right, we're going to pass in some value P. Okay, we're going to, whatever we pass into this function when we call it is going to be the variable P inside of this function. So let's just start out and print out P. Then down here, instead of this line, instead of printing out the player, what we're going to do is call print player and pass in that player. Okay, so this is the function definition. None of the code in the indentation or in the code block gets executed at the function definition time. This is a function call. That's when the code actually executes. So I'm calling the function print player. Python looks and in the file to see if it has access to a function called print player. It does, and it sees it here. And then it says, okay, you need to pass in one argument. What's your argument? This is going to be player. So for each one of the items in our offense, player is one of those values. The first time through the loop, player is the first item in our list. Okay, so we're passing in, this should be the Andrew Luck player. Now we're just going to print out the player. So nothing should change. The only thing that's changed in our output, actually nothing should change in our output. The only thing that changed in our code is that instead of having the print statement down here, we put the print statement up here and just call one quick function in our for loop. And then this function does all of the printing. Okay, but we named this well, so this tells us what we're doing. So for each player in our offense, print out that player. Print out some pretty information about that player. That's easier to read than reading all of these individual lines of code whenever we get there. Right? So when we save this, when we run it, nothing changed. That's exactly what we want. We have one item printed, then the next player printed, then the next player printed. Same thing down here. First player printed, right? But what we want to do is each time through, we want to make this prettier. So that's what we're going to do over here in this print function. We want to make it prettier. Now let's let's look. We want to use a format function. Let's make a variable output and set that equal to our format function, and then print out the output. Okay, so I'm sorry, not format function, a format string. So a string is just 2 quotation marks. Okay, if you want a format string allows you to inject different variables into your string. Okay, so it makes it nice to print out different values that are stored in variables. So you just add an F in front of your string. Alright, now what do we want? We want to the player's last name. So our variable is P now, P, and that is a dictionary. So what item in our dictionary do we want to print out? We want to print out the last name. Alright, then we're going to have a comma, and then we're going to inject another variable. We want the dictionary P, what item? The first name. Okay, so everything in the curly brackets is a variable, or it's an expression that evaluates down to some value. P is a player we passed in here. When we call the function, we're passing in player. So this argument P becomes whatever was stored in player down here. So every time I reference P, I'm referencing whatever was passed into this function. Okay, in this case, the first time through the loop, player is the first player. But the second time through the loop, player is a different player. So P is a different player the second time through the loop. Alright? But in the context of this function definition, it doesn't matter which player we have. Okay? We're always doing the same thing, so we can call it whatever variable we want. So I'm just calling it the variable P. So here we have a format string, and we have basically the last name, then a comma and a space, and then we're printing out the first name, and that's it. That's all we're doing so far. Invalid syntax. Oh, I have to use since I have double quotes on the outside here, I have to use single quotes on the inside because Python thinks the string ends whenever it sees the double quote. So I had a quotation mark here. Python considers the string to be over when it sees another double quote. So when I had a double quote here, it thought this was the string. Okay, so instead of using double quotes for the key names, I'm going to use single quotes in here. Okay, so I got an error there. It says the file is in playerdict.py, line 46, in this function call. Okay, so this function call right here at line 46, then there's an error further at line 42 in print player in that function, print output. That doesn't exist. It says it's not defined. So that was my hint that I had misspelled or had a typo in my variable. So these errors can be helpful. When you trace back in these errors, follow what it says. Alright, follow through. So we run that, and now we see our format string is working. We have the last name, comma, the first name. And notice, the second time through the loop, player is the second player. It's Marlon Mack, right? So when we call print player, this P value we get is a different player. But it doesn't matter, we do the same exact stuff. We have a format string. We're going to print out the last name, comma, space, then print out the first name. Alright, what else do we want to print out? Well, we want to have basically the parentheses, and then we want to have the player position and then their jersey number. So let's do player position, and then the number sign, curly bracket, then the number sign for their jersey number, and we'll say that is player and then jersey. Let's print that out. So here we have last name, comma, space, first name, space, parenthesis, the position, space, number sign, and then the number, and then a close parenthesis. That's what our string is doing. Okay, so that looks correct. What else do we want? We want the health of the player. So we might need to add something like we did last time, where we say health equals healthy, and then if the item at injured is true, then that means his health is injured. Okay, so now we have this health variable, and we'll put that in there. So colon health, and then we have to output what team he's on. So that's going to be player location, and then the team name, player team. Okay, so let's print that out and see. And now all of this stuff printed out correctly. Alright, now the difference between this string and this string is what we key in on. If I can't see any of this, say that's gone, and all I see is this, I really have no idea what this string is printing out. Okay, I have to have this up here that tells me what each item in this list is. With the dictionary, if I don't have any of this, I can still tell what's being printed out. So that's one of the niceties of a dictionary. It shows you, it describes your data better. As I said before, one of the hardest things in computer science is, it's commonly said that one of the hardest things in computer science is naming things. Dictionaries help because they give you more opportunities to name different values. Sometimes that can be hard, and sometimes that can be a bad thing, but most of the time it's a good thing. Alright, so this is the same program except using dictionaries, which is another way of storing a collection of data. Alright, so that's enough for the video on dictionaries.